mathematicians. Today we are working on section 12.7, which is graphing trigonometric functions. So Mr. Cresswell has given you this nice notes handout, so you don't even need to take a lot of notes today. But everything on here is really important, so I'm just going to kind of talk about what is on this sheet. So this first chart we have is super important. So first we're talking about the sine and cosine functions. So if y equals sine of theta, this is the graph of that function. The domain of that graph are all real numbers, because it can go forever in either direction on the x-axis. The range, which is y up and down, can only be between -1 and 1. If you see, this graph never goes below -1, never goes above -1. It's only in between these two. The amplitude, which over here says the height of the wave, it's really important. The amplitude is the height of the wave, how tall it is up and down, is 1. So from here to here, it's 1. From here to here, it's also 1. And then we learned about period the other day. That's how far it goes on the x-axis. That is 360. So it goes up, goes down, goes up again. Oh, it's about to cross the x-axis again. Going up like it was over here, so it's 360. It would be right here. So the period is always 360 of the sine function and the cosine function. All right, the cosine function is very, very similar to the sine function, but if you notice on the axis here, it starts at 1 instead of at 0. So it's the same graph, same pattern, just in a different location. So the domain is the same, the range is the same, the amplitude is the same, and the period is the same. So here's some basics of these graphs. Their period is 360 degrees, their amplitude is 1, sine starts at 0, 0, cosine starts at 0, 1. Really important things to remember. Then down here, this is also important information. It says, as with other functions, trigonometric functions can be transformed. For the graphs of y equals a sine b theta and y equals a cosine b theta, the amplitude is always a, but it can only be a positive number. All right, and the period is always 360 degrees over the positive of b. So those can both only be positive numbers. All right, so now we're going to get into some of that. For this section, you are going to need a calculator to try something out. So if you don't have a calculator, please go get one right now. All right, so here it says, when we graph more complicated things, we change the amplitude and the period. All right, so example 1 says, find the amplitude and period of y equals 4 cosine of 3 theta. So the amplitude is going to be 4 because A, so remember from up here, A is that number out front. So our amplitude is 4. That is the coefficient out front. All right, and remember amplitude is how much it's going up and down. Period, our B is 3 right here. That's the number before theta. So 360 degrees divided by 3 will give us 120 degrees. So this graph will make a full pattern before it gets to or in 120 degrees, and then it'll start over again. So if we were to graph that, we would want to start, since it's cosine, we know it's not going to start at 0, 0, but it will start at 0, 4 because of the amplitude, and then it would make its pattern about here is 120. All right, we are going to practice graphing in our calculator this function. So you're going to go to y equals, clear whatever's in there first. Then we need to type it in. So we have 4 times cosine, oh, wrong cosine. 4 times cosine, 3, and I'm just going to use an x. So on mine, x. And then we're going to hit graph. Oh, but Mr. Cresswell wants us to set the window to these. So I'll have to go back in and hit the window button. Change this one to -90. And this one to 450. Then we'll hit graph again. See what it gives us. So it gave us this nice graph. Awesome. So that looks just like this picture, just a lot longer than here. All right, and just a few reminders. Amplitude is the number in front of the equation, and the period can be found with the formula or from the graph. All right, now we're moving on to tangent. Mr. Cresswell says tangent looks weird, but you're just putting it in your calculator and plotting points. All right, so the parent function is y equals tangent of theta. It looks like this, so very different than sine and cosine. The domain is this fun looking thing right here. And then the range are all real numbers, because going up and down, it's just going forever. The amplitude, it's just undefined, because if we're looking at how tall this function is, well, they all keep going up forever and going down forever, so it doesn't really have a height. And the period is 180 degrees, so that would be right here, and that's where a new function, part of the function starts. Right, and here it says theta intercepts in 1 cycle. So that is also very important if you are graphing tangent by hand. All right, down here it says for the graph of y equals a tangent b theta, that would just be tangent of theta, maybe a little bit different. The period is 180 degrees divided by always a positive b. There is no amplitude. Yep, we got that. And the asymptotes are odd multiples of this. 180 degrees divided by 2 times a positive b. All right, so it says asymptotes will show up as vertical lines in your calculator. So if you're graphing it, it might look a little bit different than this, where these dotted lines are. They will just have lines in your calculator. Remember, there is no amplitude, and follow the formula to get the period. So this formula to get the period. All right, if you have any other questions, there's more help in your textbook, or I will see you tomorrow. Thanks for watching.